Hi friends, so as a part of our RGL8 journey, this time I'm going to take some topics which is related to how we can identify our hardware issues in RGL8. RGL8 is providing some utility tool and a tool also which will give you very comfortable way we can easily identify any kind of hardware issues rather than going on to the log messages or any kind of syslog messages. So these tool is also correlated with syslog and other log service, journal CTL also. Earlier we already gone through how we can configure syslog service and all things I already covered. And this time actually we, because in our day-to-day task we are always trying to make sure that our platform should be healthy, and how we can make sure that our platform is healthy. In RHEL8 we have some tool which it will give you the overview, and today we are going to discuss about those tools like MC log service, REST daemon service. And these two daemons easily, with this, after installing these two service, we can easily identify our hardware or any kind of kernel dump errors. Earlier we also discussed how we can run the diagnostics using cockpit, and we already discussed all those logs. So today we will concentrate our topic on this, because actually my platform is virtual, but there are a lot of physical machines deployed in corporate environment, and sometimes we are struggling how we can make sure that our platform is healthy, and how we can retrieve the correct log so that we can take proactive actions as well. So this time, that's why we are giving such kind of we are exploring such kind of hardware issues related sessions. So here, if you can see that a RAS daemon, in particularly in RHEL8, is a very handy utility, or you can say that program. It's a daemon which monitors the platform reliability, availability, and service availability, and give you the reports from the Linux kernel trace events. And these trace events are also logged in sys kernel tracing also. And via syslog or general-D, you can retrieve and we can query the logs. We today will see that how we can retrieve all those things, and how we can install REST, and how we can enable all disable all these services that we are going to see today. And we can see the brief usage message and all those things, and we can record the events as well, and we can query the database, general CTL database, if any event occurs, so we can easily identify our issues using RAS daemon. So now there's another utility that RAS error tracing. RAS daemon making always sure that your platform should be available, reliable, and logging tool always trace the events of any kind of critical hardware related errors, like memory, or any kind of chip, or any kind of hardware motherboard. There are a lot of components is there, so it will always try to capture those logs from that, and it will give the report to administrator, so that administrator can take a proactive actions. So we know that the MC log provides a framework for catching and logging machine checkpoint exception of x86 system. So on supported, it can also automatically mark bad areas of RAM, random access memory, so that they will not be used. we can install MC log, and after installing MC log, we can query MC log. After enabling that service, we can query this MCE log from journal CTL, and it will give the complete report. We can also, the administrator, if the administrator wants, they can use this MC log for cron jobs, and they can also dump the events in var log, MC log, and later on they can provide these dumps to service provider or anyone who wants to know about the errors and want to explore more error. They can get using MC log. We can capture all those logs. So we can install this monitoring tool, and the RAS demo is a more modern replacement. You can say the advanced feature of MC log. If both RAS demo and MC log detects the hardware errors, and also it will also trace the subsystems, also kernel trace subsystems. The main objective of this RAS daemon and MC log 2 stands for reliability, availability, and serviceability. So that's why we are installing these features. It's very good features in RHEL 8 that can uh, we can monitor our memory, disk, and other things that we will see today. And these are the main features that actually uh, so generally in identifying the hardware related, we are running some commands in uh, Red Hat 8, and Red Hat 8 is also having a one cockpit. Using cockpit, we can easily monitor our CPU, memory, and other services. So we have a RHEL 8 machine over here. We'll see how we can do all these feature, how we can install MC log, how we can do all those things. So let us go by one what exactly we have, how we can, what are the features actually we have. So let us say, if you want to know about the exact information about your CPU, the LS CPU is giving the complete information about what kind of architecture it's supporting, and what is the our how many CPU we have. You can see two CPU I have, and how many sockets, and what is the board model name, and what is the speed of CPU, and whether it is supporting virtualizations or like all the information we can capture using LSCPU. And if you are talking about the memory, using proc mem info, we can get the memory status as well. How many memory we how much memory we have, how much it is available, how much is buffers, cached, active, inactive, swap memory, if any kind of dirty regions or any kind of thing, we can easily monitor our memory and CPU related with these commands. So now, what exactly we are trying to show here? If anything, because generally DMI decode is also the good commands through which we can monitor virtual machines memory. Here it's not supporting that. So now here, if we have a storage, you can see here disk related. I have two disk, SDA and SDB, and we earlier we support like configured MariaDB and all earlier. So if I want to know how many disks we have, we can also check through this one also how many disks we have and what is the sector size. Every information we can check it from here also in RHEL, and how many bytes, how many sector, every information we can gather it from here. And if I want to know, there is another good commands over here to monitor disk related informations that I want to give you. See here, my is virtual hard disk, Dave HDA, Dave HDB, and you can see that whatever the information I want to retrieve, every information we have PCI related. So this kind of information we can retrieve from LSSCI, disk related information. Apart from that, if I want to gather more information about that particular disk, we can explore our information using HD program. Here it will give you the complete information of that particular disk, ATA devices, model number, serial number, firmware version, every information. Since I'm using virtual information, so for if you are using physical machines, it will give you the more information compared to that. So how many sectors we have, what is the logical and physical sector size, device size, every information we can retrieve it from here. And I have two disks, so I can retrieve the information from both the disks from this command. So you can see here the commands feature enabled, what are the features which is enabled, capabilities, configurations, every information we can retrieve using SD param commands. And if I want the PCI and USB, because mine is virtual disk, so it will not support, but if in physical, in case of physical machine, we can use these commands, LSPCI, LSUCB. It will give the same kind of output which whatever we are getting from LSCPU. So now let us explore, like install the MCE log so that we can see, if you can see here, I'm installing this MCE log. We have a Red Hat repository here. So we can pull the packages from Red Hat sites. So as we discussed here, MCE log, and using MCE log is also provides a framework for catching and logging. But if you are comparing MC log and REST-daemon is a good utility. We can easily detect any kind of hardware errors. We can make sure our services platform make available and serviceable always, and uh, we will check both. MC log is also, but it's a little bit older, and it can also automatically mark bad areas also. We can install both, and if we install MC log, we can query our, after enabling MC log, we can easily query our kernel trace kind of errors from journal CTLs. So here I am already given the command. So here you can see that in repository this package is available for x86 machine. So I'm installing this. So it will take some time. Now, after installing that particular service, we can enable that. We can start our service so that it will start logging and capturing those kind of hardware related errors. So here you can see here, we have already status of MCE log. It's running right now. And it's running in the background, and it will catch all those errors. And if I want to check any kind of errors, we can query those errors from journal CTL. And if I want to capture any kind of errors related to hardware related, we can use, after running that particular service, we can easily catch, and it will capture all those logs, hardware related data. Right now it's just enabled, so it's background, it's running, and it will capture all things. So journal city MCE logs, You can see here in the help menu, we have a lot of options, shows the versions of MCE log, set CPU type of decode, set the CPU to be AMD or Kate. You can do many more things, and we can log decoded machine checks in syslog files also. We can use SMB bias information to decode. So there are a lot of options we can do in foreground and background services with the MCE log. So that particularly these logs monitors you can configure with syslogs, kernels, CPU, every whatever the important trace you want. You can do all those things. You can set the CPU and CPU to decode any kind of logs you want dump. You can integrate those logs with this MC logs, and if you want any kind of background waiting for events needs in kernel, we can also query the currently running MC log daemon, and it will always log the service in journal CTL. If I am setting journal CTLs is having a lot of logs information, and particularly in order to query that particular logs, memory related or CPU related, we can easily filter after installing MC log. You can see PCI related or BIOS or any kind of events information we can retrieve from MCE log. So system D is also supporting the MCE logs and using network manager. How we can query that particular information, what kind of hardware errors happen, what kind of like log information. We can filter those logs information using MCE logs, using the commands I given. So right now the started machine check exception logging daemon. So the daemon is already running, and if any errors occurred, hardware related, it will easily catch those errors from general CTL and it will report, so that you can take and starting it will you can start the cockpit and MOTD updated service also. So it will in cockpit also this service will very helpful, this MCE logs. So now we discussed about the MC log. RAS daemon is really very good tool to make a modern replacement of MC log. MC log is also providing kernel trace subsystem, but RAS is providing more feature than stands for reliability, availability, serviceability. RAS daemon looks into error detection and corrections also. So if we install it, like if RAS looks for errors, generally these earlier monitoring tool only reporting, but RAS daemon not only looks the error, it will also try to detect if it is recoverable. So it will that is the main advantage we have for RAS daemon. So in RHEL 8, this feature is really very good, and we can take advantage of that RAS daemon as also. So let us install the RAS daemon and we will see. So I'm going to install the RAS daemon as well. So RAS daemon, what exactly the RAS daemon earlier we discussed. The RAS daemon program is a daemon which monitors the platform reliability, availability, and serviceability reports, and also the all the trace logs also getting logged in kernel debug tracing as well as journal and syslog also. So if you have in your environment, if syslog is there, and if you install MC log and RAS daemon program, you can easily filter out any kind of hardware related errors or software related errors. It will not give so much, but the hardware related errors you can easily trace out, and we can take that event. You can easily monitor our Linux kernel trace events using this tool, and we can take a lot of proactive actions as well. And so let us we have already given. So here you can say it's automatically install the DVDC. So this required package is required for installing the RAS demo. So let me install that RAS demo. So you can see here the RAS demo doing the transaction check and all this information. So these services is lot of the dependencies is there. So now we can enable the service of RAS demo. So I'm using systemctl to enable the service. So now you can start the service here. Now we can check the service whether it is running or not. So here see it's recorded with the MC. You can see event enabled. It will integrate. It will fetch the log file from MC as well as kernel trace events. So RAS daemon to log a RAS events. So it will your platform will be more secure using after installing these services. And now we will show some uh, commands. So RAS daemon. So what exactly this RAS daemon? What exactly it doing? It you can check the status using RASMCTL. RAS daemon MC log. Here you can see here. If you will use that, you can see drivers not loaded. We have a lot of options over here. You can see here. If we want to know the summary report of any kind of errors, so we can see no PCI errors, no memory errors, no MCE log errors, no EXT log errors. And if we want to know about our main board or any kind of, there are a lot of options is there here. Print labels. So mine is virtual Oracle virtual box, so it will not give so much. But in case of any kind of physical machine you are doing in Intel or any kind of client machines, you can see the errors reports here. Nothing is there. And if I want to know the layout of informations, we can. And there are a lot of options we have here, so we can utilize those options in our physical environment and load motherboard dim labels, print motherboard dim labels to the out, print a status of ERAC drivers. There are a lot of options to show the errors sorted at the error database, show the corrected and recorded error count using sysfs. This is the helpful. And we can also using journalctl command. We earlier we used that journalctl command. So here RAS command we can use that. Logs begin. So we started. We can query the RAS daemon related errors from journalctl, and if syslog is configured, we can also gather a lot of information from syslog machines and cockpit using that utility. And we can fetch a lot of records and all. So apart that, like we have a device mapper. So device mappers is also giving some information. So we can also, so here we have a VZ, we have a swap root. These kind of informations we can also retrieve from that. And we can also check our log file also. Here in var log messages, we have a lot of information. We can fetch it from here. But var log message will not gather journalctl so much information. But if we want to query, we can query from syslog. We can journalctl. We can retrieve more information from other monitoring tools. And if we have a third party installed Nagios and other MRTG or any kind of monitoring tool we have installed, we can easily configure these log files, MC, log, and RAS daemon, and we can retrieve and monitor our platform environment comfortably, and we can take a lot of proactive actions as well after using this tool. So that is the main things we have. So today we discussed about our how we can identify hardware related issues in RHEL. So in this we discussed how we can gather CPU information, PCI or memory related information, and apart from that, using SD param, how we can get more information from the disk. And we also install the MC log service and RAS daemon service, and we gone through the description of RAS daemon program, what RAS daemon program will do, how we can monitor, how the RAS daemon is monitoring the platform reliability, availability, and serviceability, that we have gone through. So I hope this information is really useful if we can implement this. And you can we also gone through the how we can install this and how we can query the log files from journal CTL. And this and the most important thing that MC log and RAS daemon you can easily configure in the cron jobs also, cron jobs, and you can take the dump events also. This thing we can do uh, using this, and I have also given some implementation on these things. So I hope this information is useful for everyone whoever is interested in RHEL 8 and wanted to configure in their environment. That this information is really handy and good information to capture anything which is related to the hardware related or system platform monitoring tool. Okay, thanks for watching. So I'm closing this session right now.